Okay, ladies and gentlemen, welcome to the video notes for Chapter 7, Section 1 in your McGraw-Hill Geometry textbook. I don't expect this lesson to take more than one video, as most students have background information on this material already. Chapter 7 is covering proportions and similarity, and Section 7.1 is covering ratios and proportions. This, again, is material we should be familiar with from junior high, as most chapters start with a section that is review material. So we start off with the definition of the word ratio. This is a vocab word. A ratio is a comparison of two numbers by division. In other words, ratio is a fancy word for everybody's favorite mathematical construct, the fraction. So here we are comparing two numbers, A and B, by division. Anytime that you compare two numbers, we generally will write the ratio as a fraction. You could also have that written as A to B with a colon in between. That means exactly the same thing. You could also have it written as A with the word 2 between it, B. Now, generally speaking, when we have a word problem, we will look for this format, A to B. When we have a non-word problem, we are looking for fractions. When we write a ratio, we want that to be in what is called simplest form. Simplest form is fancy talk for reduced. So for instance, here 5 over 10, this is not in simplest form because 5 over 10 can be reduced. The top and the bottom of that fraction can be divided by 5. Which would give us 1/2, which is in simplest form, 1 to 2. Now, it's worth noting then that there are several other things that we are never going to do here. We absolutely are never a mixed number, ever. We're never going to provide a mixed number for a ratio. Okay, ratios are never, ever, 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 ever mixed numbers. And we are almost never going to use a decimal. There are two situations where it's okay to use a decimal. Those would be if you're solving a proportion, we'll get to that in a minute, and it contains a decimal, then it's okay for your answer to be a decimal. And if you are doing a word problem and the word approximate appears in the problem, then you can use a decimal. Okay? So, let's look at a ratio word problem. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-to-teacher ratio? So, the first big thing here is we know this is a ratio word problem because there are only two numbers in the problem. If there were more than two numbers, that probably is not a ratio word problem. The other thing is it does ask for a ratio, so hopefully we recognize this as a ratio word problem. The key here is student to teacher. As soon as we see this, that is telling you which number is supposed to go on top. Because it says student to teacher, that tells us that the student number is supposed to go on top of the ratio, and the teacher number is supposed to go on the bottom. So we would set up the ratio 2,650 students to 190 teachers. Now, first things first, that ratio is not in simplest form, so one thing we can do is both of those numbers are divisible by 10. So we should start by dividing the top and bottom of that fraction by 10, which would give us 265 students to 19 teachers. This is the exact student-to-teacher ratio. But this problem does not ask for the exact student-to-teacher ratio. It asks for approximate. Now, what this means is, and this is pretty standard, if you're talking student-to-teacher ratio at your school, you are not going to provide a ratio of 265 to 19. What people want to know when they ask what is the student-to-teacher ratio is they want to know how many students are assigned to each teacher. And that number is usually approximated. So when you see this word, what we're going to do is actually divide, then round your answer to the nearest whole number. Why whole number? Because we're talking about students, so we're not going to have part of a student, okay? So we carry out that division, 265 divided by 19. So go to our calculator and we type in 265 divided by 19. That is approximately 13.94736.842. Okay, the calculator only has so many digits. But that's the thing. See, we wouldn't say that there's 0.947 of a student. What we would do is we would round that answer to state that there are about, that's where we get the approximate from, is the word about, 14 students per teacher at Logan's High School. Okay, I always tell my students that when you're solving a word problem, you should be giving a word answer. So we should answer the question with a statement, with a sentence that clearly answers the question. We've done so here. There are about 14 students per teacher at Logan's High School. Now in geometry, we're actually going to take this a step further. We're going to talk about extended ratios. It is possible to take a ratio and compare more than two numbers. In this case, this extended ratio is written as A to B to C. Okay? And you can see that as well. Okay? It could be written in that format as well. The big thing here is that we cannot use the fraction version of ratios when we're talking about an extended ratio. Okay? Because we're comparing more than two numbers, and a fraction is only capable of comparing two numbers. That's the way the construct is designed. So we're going to see these in the form of the next two examples in the notes. The ratios of the measures of the angles of a triangle, gosh, that's a mouthful, is 3 to 4 to 5. Find the measure of each angle. So a lot of times in geometry, it's helpful to draw a picture. So we're going to draw a triangle. It doesn't matter what our triangle looks like because we're only using it to organize our thoughts. Now we do not know the measures of the angles in that triangle, but we do know that they are in the ratio 3 to 4 to 5, which means one of the angles is 3 times some variable. We're going to use x because that's the one that most students are comfortable with. One angle is 4 times x, and one angle is 5 times x. Now, if you've been working through this book in the order that it's intended to be worked through, you've done 1,000 of these problems in chapters 3 and 4. Well, actually, it's chapter 4 mostly. If we know the three angles in a triangle, we should know that those three angles always add up to 180 degrees. So by giving you the ratios of the angles, they have allowed you to write the equation 3x plus 4x plus 5x is equal to the sum of the angles in any triangle, 180 degrees. Setting up this equation allows you to solve for x. So add together your like terms. 3x plus 4x plus 5x is 12x equals 180. And then divide by 12, which gives us that x equals 15. Okay? Now that does not finish the problem because we weren't asked find x. We were asked to find the measure of the angles. Well, those angles are 3 times x, 4 times x, and 5 times x. So once we have x, all we have to do is plug in. 3 times x, 3 times 15 would be a 45-degree angle. The second angle is 4 times 15, which would be 60 degrees. And the third and final angle is 5 times 15, or 75 degrees. We can check those answers by adding them up, 45 plus 60 plus 75, and they should add up to 180 if we didn't make any mistakes, which they do. So our answer to the question is the angles are 45 degrees, 60 degrees, and 75 degrees. At this point, you should pause the video and try the next example. Please be careful, as it is not an angle measure problem, so those will not add up to 180 in the next problem. They will add up to something else you're going to have to think. So pause the video and try it. If you get stuck, then resume the video. That's fine, but please try the next example before you continue. Okay, so here once again we have the ratios of the measures, this time of the side lengths of a triangle is 2 to 2 to 3. And then they give us the perimeters, 392 inches. They ask us to find the length of each side. So once again, we're going to draw a triangle, and we're going to label those side lengths 2x, 2x, and 3x. Your picture does not matter in terms of accuracy because we're only using it to organize our thoughts. Now, once we have information about the three side lengths, if we add those three side lengths together, they don't add up to 180 because when you add side lengths, that is the perimeter. Yeah? So if we do 3x plus 2x plus 2x, that should equal the perimeter, 392 inches. Then we solve for x, just like we did in the last example. 2x plus 2x plus 3x is 7x equals 392. And we divide by 7, and we get x is 56. Again, once we have x, we can find the side length simply by plugging in x. First side is 2 times x, or 112. Units is inches because the perimeter is in inches up here at the top. That tells us that these measurements are going to be in inches. The second side is also 2 times 56, or 112 inches. And the third side is 3 times 56, which would be 168 inches. Once again, you can check your answer by adding those up. In this case, they should add up to the perimeter, 392, which they do. The final piece of section 7.1 deals with proportions. A proportion is defined as being an equation stating that two or potentially more, which we'll see in the next section, ratios are equal. Okay? This is a vocabulary word. You should be aware of it for vocabulary quizzes in the future. Now, there's some outdated vocabulary that goes with this. The way we solve a proportion, when we should have done in junior high, we should have solved proportions in junior high, is we cross multiply. So the cross products, B times C, is known as the means. And the other cross product, A times D, is known as the extremes. Now that vocabulary is outdated. It's not something we really need to know anymore, at least not until we talk about geometric mean later in the chapter. But it's worth noting that the means is always equal to the extremes. In other words, for every single proportion, B times C is equal to A times D, always. Okay? Now, I do expect in your work to see this equation every single time. In junior high, when we were always dealing with, proportions that only contain just a variable and three numbers, we get in this habit of coming up with a shortcut where we just cross multiply and divide, cross multiply and divide, cross multiply and divide. And that'll work on problems like letter A below, but it will not work on problems like letter B below. So now that we're in high school, I do expect you to write out this equation each time. So let's do some examples. In letter A, again, we're going to cross multiply. So we're going to do x times 21, which would be 21x, equals 6 times 31.5. Again, you've got a calculator, so that shouldn't be any big deal for us to do. That is going to be 189. Again, I expect to see this equation. To solve that equation, we simply divide both sides by 21. And we get that x equals 9. On letter B, same idea. We cross multiply. 4x times 2 is 8x. And here's where we run into a problem if we're trying to come up with a shortcut. The other side is 5 times the quantity x plus 3. I want to see that equation. I want to see it before you distribute. So to solve that, we distribute the 5, which would be 8x equals 5x plus 15. Excuse me. Then subtract 5x from each side, which would give you 3x equals 15. Then divide by 3, which would give us x equals 5. So that's how you solve a proportion. You cross multiply to get the equation means equals extremes, and then you solve that equation. It's going to be a linear equation, which should not be any big deal. Okay, finally, here's a word problem. Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to his school, predict the total number who own cars. So anytime that we see a word problem that contains more than 2 numbers, it's probably a proportion word problem in this section. So when you see a proportion word problem, they're going to give you one full set of information, one full ratio, which they do here talking about Fernando's survey. 50 students drive to school. Of those, 28 students own cars. Okay? On the other side of your proportion, we've got one more number, and that is that 755 students at Fernando's school drive to school. So the big key here is that we've got to get that number in the correct place. So we have to ask ourselves, is 755 a number that relates to 50 or 28? That's where the units come in. This number is talking about students that drive to school. So 755 would be paired with 50 because it has the same units. That's students that drive to school. We're trying to predict how many of those students own cars, so that's where our variable goes. From there, what we're doing is we're cross-multiplying. Okay, so we've got this equation. And by the way, you could just as easily have flipped both fractions. As long as 50 and 755 are on the same side of the fraction, both on top, you're good. Okay? So now we have this proportion. 50 is to 28 as 755 is to x. Conversely, you could have also had the same exact thing but flipped. We cross multiply. So 28 times 755 is, use your calculator, 21,140 equals 50 times x, which would be 50x. That is a one-step equation we need to solve, so we divide by 50 on both sides. That gives us x is equal to, I'm going to need to grab my calculator here because I don't, as good as I am, my brain is not feeling like dividing that in my head. 422.8. Now again, that's an exact answer, by the way. We aren't going to have 0.8 of a student, so we would say about, because we're going to round, 423 students, because we're going to round 422.8 up, because 8 is bigger than 5, at Fernando's school own cars. Okay, it's a word problem. We answer with a complete thought. That does it for Chapter 7, Section 1. Thank you very much for your time and attention.